Section 3.1 deals specifically with substances that dissolve in water. Now, these substances can be divided into categories of chemical compounds. Now, these categories of chemical compounds vary greatly in their physical and chemical properties. Two types of chemical compounds that are discussed in Section 3.1 are ionic compounds and molecular compounds. Ionic compounds are created by the interaction of cations and anions. Let me give you an example. The lithium ion, it forms a positive ion, a cation, and a fluorine ion. What type of ion is that? An anion. These will combine, and it can be written like this. That is an example of an ionic compound. It is a cation plus an anion. You can also think of it as a metal plus a nonmetal, or a left side element plus a right side element on the periodic table. Let's look at the molecular compounds. A molecular compound, an example would be carbon dioxide. Carbon dioxide is an example of a molecular compound. The interaction between these two elements makes a molecular compound or a molecule. It is the right side of the periodic table plus the right side of the periodic table. Ionic and molecular compounds have various chemical properties and physical properties. Let's turn to page 87 in your text. You'll find this picture. I have 3 light bulbs here. Each light bulb is in a solution, a different solution. This solution is pure water. This solution is an aqueous sugar solution, and this solution is an aqueous NaCl solution, or sodium chloride solution. Aqueous means in water. This test helps us determine the water's electrical conductivity based on the solution. Pure water does not conduct electricity. Aqueous sugar solution does not conduct electricity, but the aqueous solution with NaCl does. NaCl is an ionic compound. Therefore, we know that an ionic compound dissociated in water does conduct electricity. This is also known as an electrolyte. Molecular compounds are usually non-electrolytes. Here's a problem for us. I have 6 compounds here. Which of these compounds, and there can be more than one, are ionic compounds? Now let's remember, ionic compounds are a nonmetal and a metal. So let's look here first. Sodium and chlorine. Great. We have a metal and a nonmetal. That's ionic. Magnesium and oxygen. Perfect. Metal, nonmetal. Hydrogen and oxygen. Nonmetal, nonmetal. What about carbon and oxygen? Both are nonmetals. What about H2O? Hydrogen and oxygen, both nonmetals. What about calcium and oxygen? This is a metal, this is a nonmetal. So those 3 are ionic compounds. Next question, which of these are molecular compounds? Well, molecular compounds are nonmetal combining with nonmetal elements. These 3 are all examples of molecular compounds. This is regular table salt, NaCl, or sodium chloride. If I put this in water, what happens? Well, when a compound composed of ions separates into cations and anions, this process is called dissociation. But my question to you is, what does sodium chloride look like before it dissociates? The answer to that question can be found on page 89 of your textbook, and it looks like this. The arrangement of cations and anions in an ionic solid such as sodium chloride actually forms a crystal structure or crystal lattice. The strong attraction between the oppositely charged ions, sodium and chlorine, along with this pattern right here, give ionic solids their unique properties. They are solids at room temperature, have very high melting points, and are extremely brittle. You can represent salt dissolving in water with this equation. Sodium chloride, which is a solid, interacts with water, and it dissociates into the sodium ion and the chloride ion. This symbol right here, AQ in parentheses, is put as a subscript for the ions because they are in aqueous solution. They are in water. Molecular compounds, however, usually remain as molecules when dissolved in water. They can exist as solids, liquids, or gases at room temperature, and they also have a much lower boiling and melting point compared to ionic compounds.